Have you ever wondered why diesel engines were never introduced into aviation? I didn't give it much thought, and honestly, it never crossed my mind, until I discovered a fascinating article in my father's aviation magazine collection. In the late 1920s, the aviation industry was on the cusp of a technological revolution. The rapid advancements in aircraft design and engine technology were pushing the boundaries of what was possible in the skies. Among the most significant developments of the era was the introduction of the diesel engine as a viable power source for aircraft. This article, originally published in the August 1929 issue of Aeronautics by Edward A. Stinson, chronicles the pioneering efforts of the Packard Motor Car Company in testing and refining this new engine technology. Through a detailed account of the rigorous testing process, including the successful adaptation of a Stinson Detroiter airplane, Stinson provides a rare glimpse into the challenges and triumphs of early aviation engineering. The difficulties they faced, from technical issues to safety concerns, are a testament to the relentless pursuit of innovation that defined the golden age of aviation.
And now, The Diesel, by Edward A. Stinson, published in Aeronautics, August 1929. With all the conflicting stories relating to the development of the diesel engine as a motive power for aircraft, it might be well to give the actual facts about the one engine which has made a public appearance. Late in the summer of 1928, the Packard Motor Car Company of Detroit purchased a 6-passenger Stinson Detroiter from the Stinson Aircraft Corporation in order to make exhaustive flying tests of their new diesel aircraft engine. The plane was a standard model, one which is ordinarily equipped with a 225-horsepower Wright J5 Whirlwind engine. In accordance with instructions, the plane was delivered to the Packard Motor Car Company without the engine mounting or the exhaust ring. This construction detail was left strictly to the Packard engineers, since absolute secrecy surrounded their research work with the diesel engine. Upon satisfactory installation of the diesel engine, the entire plane was carefully checked by a Stinson serviceman, and the first test flights were made from the Packard proving grounds near Utica, Michigan. So that conditions might duplicate those of actual service as closely as possible, no changes were made in the plane itself. It was fitted with dual wheel control. Every comfort for the 6 passengers was fitted. There was a baggage compartment located at the rear of the cabin with access from an interior door, and the plane was finished in a black and orange color combination. Constructionally, the plane was standard, with a seamless steel tubing fuselage. The entire plane was fabric covered and treated with 6 coats of dope before the final color coat was applied. The airfoil section was the M6 curve, and wings were made of one-piece spruce spars with spruce ribs and Warren Truss reinforced compression tubes. Mention of successful flights seldom appeared in the newsprints. Many flights were made, however, and there was a good deal of unconfirmed rumor concerning the new engine. One epical flight was made, with a famous celebrity as a passenger. Readers will remember the visit of the Crown Prince of Spain, who was an aviation enthusiast, to the United States. While in Detroit, he was the guest of Alvin McCauley, president of the Packard Motor Car Company. It was during this visit that he made a short trip in the diesel-equipped plane with Captain Wilson and W. E. Lees, the company's test pilot. The Crown Prince was highly enthusiastic over the performance of the plane with the new motor. Late in the spring of 1929, sufficient progress had been made with the diesel engine so that a public announcement could be made safely. The 4th Annual Aeronautical Conference of the National Advisory Committee for Aeronautics was to be held in Washington the week of May 12th, and it was decided to announce publicly the engine at that time. Accordingly, the Stinson Detroiter was made ready for the flight, and early Tuesday morning, May 14th, Captain L. M. Woolson, chief designer of the engine, hopped off with W. E. Lees, pilot, for Langley Field. The flight from Detroit to the field required approximately 7 hours and was made at an average speed of 85 miles an hour. The distance flown totaled 685 miles due to the particular course followed by pilot Lees. Upon their arrival, Woolson sent the following wire. Arrived after 6 hours and 50 minutes uneventful flight, consuming $4.68 worth of furnace oil. As the fuel oil the diesel burns costs 8.7 cents per gallon, Woolson's consumption of $4.68 worth equals 54 gallons. A 200-horsepower gas engine, burning aviation gasoline, which costs about 30 cents per gallon, would consume 13 gallons per hour, or 78 gallons in 6 hours, at a cost of $23.40. On his departure from Detroit, Wilson carried more than 100 gallons of oil, sufficient for his return without refueling. The fact that he could take the plane such a distance without special rigging for starting dispels the rumors which have claimed that the problem of starting a high compression engine, such as the diesel, was one that could only be met with special equipment. Although the diesel weighs more than gasoline engines of equal horsepower, estimated at 3 pounds per horsepower as compared to 2 pounds per horsepower, the difference is more than compensated by the disparity in weight of required fuel loads. There are 9 cylinders in the Packard diesel, which operate independently of each other, giving the effect of 9 different engines. Another advantage will be lack of radio interference while a plane is communicating with the ground, since the construction of the engines requires no electrical apparatus for ignition purposes. Carburation points are eliminated, greatly reducing the fire hazard. According to Packard officials, the choice of airplane equipment for test purposes on the new diesel engine reached around several types of plane. Final choice of Stinson equipment resulted from their ability to carry the heaviest loads with full dependability and low horsepower engine rating. Besides being used for exclusive tests on the diesel engine, Stinson planes are also being used by the Continental Motors Corporation of Detroit, the Warner Aircraft Company, and on the new series of Lycoming engines now being tested by the Auburn Motor Company of Auburn, Indiana.
The introduction of the diesel engine into aviation marked a pivotal moment in the evolution of aircraft technology. As detailed in this article, the successful testing and public unveiling of Packard's diesel engine not only demonstrated its efficiency and reliability, but also its potential to revolutionize the future of flight, sparking a wave of optimism and excitement in the aviation community. This potential for a new era in aviation is a testament to the enduring spirit of innovation in the industry. The collaboration between the Packard Motor Car Company and Stinson Aircraft Corporation was a testament to the spirit of innovation that drove the aviation industry forward during this era. Their joint efforts faced numerous challenges, from technical issues to safety concerns, but they persevered, pushing the boundaries of what was possible in aviation. As we reflect on these early developments, it becomes clear that the diesel engine was more than just a technical achievement. It symbolized the boundless possibilities ahead for aviation. Today, as we continue to push the boundaries of aerospace technology, the pioneering work captured in this article remains a source of inspiration. It serves as a powerful reminder of the enduring impact of those who dared to dream and push the limits of what was possible, instilling in us a deep sense of respect for the history of aviation. Their contributions have shaped the industry we know today. Now let's delve into the reasons why the diesel engine, despite its initial promise, failed as a viable power option in aviation. This exploration will provide valuable insights into the challenges and complexities of aircraft engine technology. The diesel engine, despite its initial promise, was not fully adopted in aviation for several reasons. Diesel engines, while more fuel-efficient than gasoline engines, were heavier. This higher weight translated into a lower power-to-weight ratio compared to gasoline engines. In aviation, where weight is a critical factor, this disadvantage became a significant drawback, limiting aircraft performance and payload capacity. Diesel engines typically generate more vibration than gasoline engines. This increased vibration was challenging to manage in aircraft, where smooth operation is crucial for structural integrity and passenger comfort. Historically, diesel engines have been harder to start in cold weather than gasoline engines. This posed a significant problem for aviation, especially in higher altitudes or colder climates where reliable engine startup is critical for safety. During the same period that diesel engines were being tested for aviation, significant advancements were made in gasoline engine technology. These engines were becoming more powerful, reliable, and efficient, which reduced the perceived need to switch to diesel engines. The improvements in gasoline engines outpaced the development of diesel engines, making the latter less attractive. Diesel engines were more complex and expensive to produce than their gasoline counterparts. The cost of developing, manufacturing, and maintaining diesel engines was higher, which made them less appealing to aircraft manufacturers and operators, especially when gasoline engines were already well established and cost-effective. The lack of widespread adoption meant fewer resources were dedicated to developing and refining diesel technology for aviation. As a result, diesel engines didn't benefit from the same innovation and mass production level as gasoline engines. The limited use in aviation also meant less operational data and experience to improve the technology further. The onset of World War II and the urgent need for reliable, powerful aircraft engines led to a focus on gasoline engines, which were already in widespread use and could be rapidly developed and produced. After the war, the introduction of jet engines further diminished the relevance of diesel engines in aviation, as jet engines offered superior performance for most military and commercial applications. While diesel engines offered some advantages, particularly in fuel efficiency and operating costs, the combination of technical challenges, competition from improved gasoline engines, and the rise of jet propulsion ultimately limited their adoption in aviation. Diesel engines found more success in other applications, such as marine and industrial settings, where their characteristics were better suited to the operational requirements. Well, I hope you got something from this article. I sure did. Now we come to another ending in Tony's short stories. Thanks again, and I'll see you in the next one.